right, section 5.2, moving on to example number 2. In example number 2, I've got two fractions on the right-hand side, so I'm going to start there. And if I have two fractions, I'm going to start by combining them. In other words, in this case, I'm adding them. In order to add fractions, I need a common denominator. My common denominator for this one is going to be this guy times this guy. It's going to be long. So cosecant x plus cotangent x times cosecant x minus cotangent x. All right, since we've got some fraction math here, to go from our first denominator to our common denominator, we multiply it by this second denominator. So I need to multiply the 1 times this guy. Since it's just 1, this is going to be cosecant x minus cotangent x. And then for our second denominator, to go from that denominator to the common denominator, we multiply by the first denominator. So I'm going to multiply 1 times this denominator, and that's cosecant x plus cotangent x. Now I have a cotangent x minus cotangent x in the numerator. Those guys will cancel each other out. And I'm left with 2 cosecants up there. So 2 cosecant x. On the bottom, these guys are conjugates. What makes them conjugates? The first terms are the same, last terms are the same. The only thing that is changed is the sign in the middle. So these guys are conjugate. And what's special about the conjugate is those middle terms will drop out. So let's see that in action. Cosecant times cosecant is cosecant squared x. And then I've got cotangent cosecant x, and the negative cotangent cosecant x. And the positive and the negative cancel each other out. That's why we love conjugates. And then cotangent x times negative cotangent x would be negative cotangent squared x. Our trig identity that has both cotangent in it and cosecant in it is this one. And I want cosecant squared x minus cotangent. So I'm going to move this guy to the other side. And I get that cosecant squared x minus cotangent squared x is equal to 1. So this guy here on the bottom is just 1. And so we get 2 cosecant x over 1, which is just 2 cosecant x. We're done. All right, let's look at the U-try for this one. This time we're working on the left-hand side. We're going to start by combining our fractions. We need a common denominator. This time it's 1 plus sine theta, 1 minus sine theta. What do you notice about those two guys? Hopefully you said they're conjugates, Ms. Harris. All right, to go from here to here, we have to multiply by this guy. So I need cosine times this guy on the top. Cosine theta times 1 minus sine theta. And then we have to deal with our second fraction. So plus, to go from here to here, we have to multiply by the first denominator. So this is going to be cosine theta. They're going to run out of room. Times 1 plus sine theta. All right, distributing out that numerator, I've got cosine times 1 is cosine theta. Cosine times negative sine theta, I'm going to call that negative sine theta cosine theta. Again, cosine times 1 is cosine theta. And then cosine times positive sine theta. So, sine theta cosine theta. All that's going to be over our denominator. Conjugate, so it's really just 1 times 1, which is 1. Middle terms will cancel out. Sine times negative sine is negative sine squared theta. For this one in my numerator, notice you have a positive sine theta cosine theta and a negative sine theta cosine theta. So those guys will cancel off. And we're left with 2 cosine theta on the top. On the bottom, I have 1 minus sine squared theta. Remember, we know sine squared x plus cosine squared x is equal to 1. If I move the 1 over, 1 minus sine squared theta is equal to cosine squared theta. So at the bottom, I've got cosine squared theta. One of these cosines will cancel out, and I've got 2 over cosine theta. The reciprocal of cosine theta is secant theta. So this is the same thing as 2 times, not 1 over cosine theta, but secant theta. And that's where we're trying to get to. All right, there's example number 2. Next video will be example number 3.